Hello chemistry people, Amy here. Doing another one of my experiment videos, this time for 18.3 in the higher level curriculum, looking at pH curves. Now, as I do the actual experiment, I'm going to speed up the film because otherwise we would be here all day. So I'm just going to pause this recording and then turn my camera so you can see how I've got everything set up. So I don't have any solutions in here yet, but what I've got is a hot plate with a stirrer. I'm only going to be using the stirring function. I've got a beaker. I know that we would normally use conical flasks for titrations, but because I'm using the pH probe, a conical flask doesn't work. I then have a burette, which is going to have our solution in it. Now, the first combination that I'm going to try is a strong acid in my burette and a strong base in my flask down the bottom. I'm also going to add a little bit of universal indicator, just so we can also get a qualitative idea of what's happening to the pH in these containers. Okay, so let me just pause and get my solutions ready. Okay, so I've got a full burette of 1 mole per DM3 hydrochloric acid, and I'm now going to add 40 CN3 of sodium hydroxide into this beaker. Now, when you look at questions on IB exams, they will generally use smaller volumes. I just found from setting this up so that the pH probe was in the solution, I just found I needed to have about 40 CN3 so that I could have the probe submerged and have the magnetic pellet stirring. So the reason I'm using a magnetic stirring pellet is because in a normal titration, I would swirl the container to make sure that what's going in from my burette is mixed through. However, because of the whole setup I've got, I can't really swirl. Yes, you can see that. So what I'm going to do, I'm going to pause again, and then fingers crossed when we come back, you will be seeing a split screen of this experiment and the feed from the Bluetooth pH meter. So keep your fingers crossed. Okay, so hopefully you are seeing my screen at the moment. What I've got here on the left is the Pasco SparkView app. I'm just going to add just three drops of the universal indicator in there. And I'm going to put my stirrer on, just so we can see that that indicator gets mixed through, and making sure that that pellet is close to the middle of my solution. So I've got my HCl already set up the top, and I'm just going to change my sampling rate to, it doesn't need to be 5 times per second. Let's do it every 2 seconds. And what I'm going to do, I am going to turn on the burette so that the acid drips into this container at a constant rate. And I might move this a little closer so you can see, yes, that solution quite clearly. So excuse my leaning. Let's do that. So if I press start, that should start recording. Yay. So I'm just going to let that run now. Oh, once I turn my acid on. Oh, no, too much. Okay, yes, so that is dripping at a constant rate now.
Hi. So a couple of things I need to quickly explain. With the video, I have compressed it and taken out the sound for the duration of the experiment. And you will see me squirting some, like pulling some of the liquid out of the beaker. That's because I was worried about that beaker overflowing. So periodically you will see me sort of dipping in there and pipetting out, just using one of the plastic squidgy pipettes, some of the liquid that's in that beaker at the bottom of the, catching the liquid out of the burette. You also see me sometimes adding some more indicator. I also did that a couple of times. And you may see me occasionally climbing up on a chair to refill the burette. So if there's a bunch of movement going on, that's probably it. Please enjoy the show.
Okay, so that was a strong acid and a strong base. I am just going to... Okay, so let's try that one again now that I've got the correct solution in there. So this is sodium carbonate, which as you can see has turned my indicator purple, which indicates that it is basic. Let's double check by activating my yes and turning on my HCl, turning on my HCl to a, no, that's a bit too fast of a drop. That will do. Let me just, oh, no, too far. There we go. Nice steady drop, which you can't see, but I know is there, and that's the important bit. I added this little bit of a video for some qualitative observations, so you should be able to see bubbles forming in that solution. Think back to SL acids and bases. Okay, so I was a little bit cheeky with that one. You will notice that there are 2 equivalence points in it. What I'd like you to do, can you write down the formula for the carbonate ion and then think about why there might be those 2 equivalence points? Okay, so those were the 2 with our strong acid. I'm now going to rinse out my glassware and we're going to go again, but with a weak acid up in our burette. So give me just a second to pause and reset everything, and then we'll be back. Increase it up in size. So again, so this is still on every 2 seconds. Let's start that and let's get our burette going. And I want a solid drip, but not too much. Yes, that looks solid. So let's just let that run. Okay, so I'm actually going to cut that one a bit short because I really want to do our last titration and I'm nearly out of time. So let me pause, reset, and then we'll continue. Okay, and for this last one, I have sodium carbonate, which is the same weak base I used before, against ethanoic acid. So let me do share screen, spark view, and let me do the thingy thing where I change the size of this. And are you seeing that? Yes, you are. Are you seeing that? I hope you are. So it's still set to 2 seconds. So if I turn this on so it spins, press this so it records, and then turn this so it's dripping. Yep. Okay, so thank you for that. If I find a decent looking data set, I might either put up on my channel or send to my students a data set for these graphs, and just to have a look at how we can measure turning points and things like that. Thank you so much. Have a fantastic rest of your day, and I will see you next time. Bye.